Space junk, the final frontier. Let's take a look at what space junk is. So first, there's natural space junk, there's comets and asteroids, there's artificial. Let me move this little picture. It's just a little graphic. You're going to see some really cool graphics soon. Artificial, which is satellite breakup, paint flakes, even paint flakes, as you read in the introduction, can cause some major damage if it hits something and that's through its path. Tools, thermal blankets, these can all be things that are space junk. Human refuse that is ejected or eliminated out of the space station. And so some statistics for this. So these would be some things to note down in your notes, that there are 28,000 objects created since 1957. That doesn't mean 28,000 objects were launched. They're not 28,000 satellites. 9,000 of them are still in orbit, so that means a big chunk of them have fallen and back to Earth or burned up in the atmosphere, but only 550 are useful. So we have a lot of just junk that is serving no purpose. And if you consider that there are 75 launches per year, there's a lot of opportunity for an increase in space junk, or good space objects and space junk. It is increasing, so I'm going to show you right now a really cool couple sets of videos and images to demonstrate this. Is a graphic, again, you've already seen the video of it, but a graphic of 1967 and then of 2007. And I'm hoping that you notice this ring and that you did on that video also. This ring here that's way out in orbit has some particular significance, which we're going to learn more about in orbital mechanics unit, but that will come into play. So space junk impact. Is there a danger? Well, low Earth orbit, or LEO debris. Again, you're going to learn more about low Earth orbit later on. But it can travel, or travels at 18,000 miles per hour, which is ridiculous. And that's where paint flecks can cause some even serious damage, just even in themselves. Energy, if you think of kinetic energy, 1/2 mv squared, it has tremendous kinetic energy. So the question of how long will it orbit? If it's in low Earth orbit, it could just be for days, because it will be attracted to the Earth, and it slows down. Even though you're so far away, there still is atmosphere enough to slow it down. So it'll slow down at speed, and it'll be in orbital decay, and it will fall down to Earth. Once you're 200 to 600 kilometers away, as long as it's just junk and there's nothing to keep it at altitude, it could orbit for years before it burns up in the atmosphere. And then so on and so on until you get greater than 36,000 kilometers, where it would orbit forever. It does not need additional attitude adjustments or altitude bursts to keep it in orbit. It will just continue to orbit around the Earth or just be out in space. So we do have ways to track it. Spacecraft are designed to have tracking systems that measure object size less than 0.1 centimeter, so a millimeter in size. Again, thinking these paint flecks, it's really important that they know if there are things around. There are millions of little tiny objects. We're not talking the larger objects that I mentioned before in that 9,000 number. There's millions of tiny little objects, paint flecks and things like that they need to make sure that they're either going the same speed as, if it's in low Earth orbit, or that they aren't going to cause any damage. There's telescopes and radar tracking. There are greater than 100,000 objects that are greater than 0.5 centimeters, so 5 millimeters. For objects that are greater than 10 centimeters, there's optical tracking, because it's big enough we can see now. And there is about 11,000 objects. And this is requiring a multinational effort now. NASA has created a program, the Orbital Degree Program Office, to work in tracking some of these things. European Space Operations Center also has something for space junk tracking. So here's a neat little some images here that are tracking. So Things that they can do are advise orbit changes. So when they see things that are going to collide, then you can contact the agency that is responsible for that particular satellite, and you are asking them to use their attitude adjusters and adjust its orbit in whatever direction. It's almost like flight traffic control, where they're trying to change orbits to make sure things don't collide. Because if they do, then you have space junk impacts. And so here's a few incidents. We had these 5 here that are just a couple we'll note. One was a briefcase size. It went 31,500 miles an hour as it's hitting the ground. This is South African land strike. Something in Texas. We had another South African one in 2000. There's been some satellite and shuttle windshield strikes that have actually hit the space shuttle and have hit satellites. So you're going to look at some of these incidences yourself in the project coming up. One thing that a gentleman by the name of Donald Kessler published in 1978 was a Kessler syndrome, where he was looking at satellite collision and how it generates fragments and trying to track these, because these fragments can cause exponential increase in other collisions. As they explode, they hit other things that begin to break apart, and it causes exponential growth, and it causes a growth of the debris belt, which could potentially block other craft from that altitude or above, making sort of a cloud that we can't get through because there's too much debris and it's too dangerous to try to push through it. So that is one of the potential risks that we face at the moment. So here's a little image showing the actual collision. And so they can sort of try to predict, if they hit, possible debris and where it's all going to go. So the goal in space junk reduction is to limit the creation of the space junk, obviously, limit the explosions with better equipment, and how much that it would break apart. To make a graveyard orbit above popular geosynchronous orbit. You're going to learn about geosynchronous orbit later. But to make a graveyard orbit there, where you are collecting and pushing things out of our usable orbit of space right now, and then just to simply to clean up the mess. So these are some areas that you may look further into when you're coming up with your own solution. And that's it for right now.